what I like to do is show you how to find the axis of symmetry when given a function negative x plus 1 squared plus 4. So remember the axis of symmetry, if you remember a parabola, my parabola, without any transformations, well, that's kind of bad, probably looks something like that. My parabola without any transformations is reflexive about my y-axis, all right? So this is my axis of symmetry. And in this case, my axis of symmetry is when x is equal to 0, all right? And this is for the parent function y equals x squared. Now, to find the axis of symmetry when given a function with transformations, there's a couple ways you can look at this. One thing is the axis of symmetry is not going to change if I move my graph up or down at all, right? And it's not really going to change if I expand or condense my graph. The only way my graph, or reflected about the xy axis, the only way it's going to change is when I shift it left or right. So I know by knowing my transformations that this graph, since x plus 1, that tells me I'm going to shift my graph 1 unit to the left. So actually this graph is going to be shifted this unit. So therefore, since my vertex is on my axis of symmetry, my new axis of symmetry is at -1. Now let's look at an algebraic way to solve for this. There is a formula for the axis of symmetry. And the formula for axis of symmetry is opposite of b over 2a. Jeez. And where am I getting this ab? Well, remember every function can be, or quadratic, can be written in the form of ax squared plus bx plus c. So therefore, this equation is not written in ax squared plus bx plus c format, but I can rewrite it in that format. If I was to expand this equation, x plus 1 squared is x squared plus 2x plus 1 plus 4, distribute my negative sign, minus, so negative, so minus 1, 1 minus 1 is -1, plus 4 is positive 3. All right, so therefore, if I have that, now if I take a look at this and say, well, the opposite of b, which would be a positive 2, divided by 2 times a, which is -1. And that answer gives me x equals a -1, which again is the same answer that I very quickly and easily found by just using my transformations. But that's how you find the axis of symmetry algebraically and graphically.